Section 6.5, Laws of Thermodynamics. So thermodynamics refers to the movement of heat. And so we've talked a bit about how we measure heat and that it's thermal energy that's exchanged, and we've talked about temperature scales. And so we can kind of put all these things together, and as you'll see, we can talk about some specific laws about how heat behaves. So the first law of thermodynamics just refers to what is essentially the idea of energy conservation. When you have some object that transfers thermal energy as heat, then the energy that's lost as heat from that object has to be gained by something else, or it has to be used to do something. And from that, we get the first law of thermodynamics, which is the idea that when heat flows to or from a system, the system gains or loses an amount of energy equal to the amount of heat transferred. All that basically means is that when you have some thermal energy that's transferred as heat, either the system's thermal energy will increase, so it's absorbed some heat, it's absorbed some thermal energy, and so the thermal energy of that system increases, or the system will do some type of work on its surroundings. So you're heating up water, and that water will rise up and spin a turbine, or something to that effect. So the heat does some kind of work on some object. But no matter what, the heat that's exchanged goes somewhere. That energy does not disappear. It goes somewhere, or it's used to do something. Now, the second law of thermodynamics we've kind of talked about already. It basically just says that heat never spontaneously flows from a cold substance to a hot substance. It's always the other way around. If you touch something that feels cold, like a piece of ice, it's not that the ice is cooling your hand. The ice is pulling thermal energy away from your hand so that it feels colder. And as it pulls that energy away, you feel the temperature of your fingers go down. What's actually happening is that your fingers are heating the ice. Another example is when you put water in the freezer to make ice, that water actually warms the inside of the freezer. But as it's doing it, because the inside of the freezer is a much lower temperature than the water in the container loses all of its thermal energy to the freezer, and it then turns into ice. It goes to the same temperature as its surroundings. Now, over time, you would think that if that was true, it would heat up your freezer. But the reason that a refrigerator and a freezer work the way they do is because electricity runs a coolant system that keeps the temperature at a particular level. So it's always removing the heat provided by the objects that you put in the freezer. It removes the heat as it cools those objects and brings them down to 30 degrees Fahrenheit or whatever the temperature of your freezer is set. The third law of thermodynamics is something else that we've already talked about. It's the idea that no system, no matter what it is, can reach absolute zero. You can get close, but you can never get there. And this can kind of be understood if you understand the idea of absolute zero and how you could possibly measure it. So for example, let's say we have a system that we think is at absolute zero. That means the particles inside of those objects are not moving at all. Nothing is moving, everything is standing still. If we wanted to measure it, even if we just looked at it, when you see something, the reason that you see it is because light bounces off of it and then hits your eye. So the act of actually viewing or observing something that we thought was at absolute zero would have to introduce some amount of energy into that system. When the light reflects off, it hits something, and when it hits it, it causes it to move. And so then that object is moving, and now the system is no longer at absolute zero. So in general, there's no way to get anything down to absolute zero. And even if there was some way, you couldn't measure it. So in labs, they've been able to get down to many decimal places close to absolute zero, but you can never get to that value.